In the previous video, we had talked about the logistic regressions and how we saw how logistic regressions takes the inputs and computes the weighted sum as well as the probabilities. And based on that probability, it calculates the loss and reduces the loss by updating the parameters W and B through gradient descent methods. And in this video, I will show you how we can relate the logistic regressions to neural network. And as I mentioned it before, the concepts of neural network and logistic regressions are quite similar. But of course, neural networks can be much more complex in reality. But for understanding the concept, neural network can still be considered to be formed by stacking together a lot of the sigmoid units, and but in that case, you can think of that a neural network is little more than several logistic regressions models that are stacking with each others. Similar to the logistic regressions, there are two main steps in neural network. The first step is the parameters initializations. Again, there's two key parameters that we need to initialize. That is W and that is the bias B. And then we create a for loops that is another hyperparameters epoch that we need to decide. And that is what we need to decide when we stop this loop, when we break this loop. And of course, we also have three key steps. That is the forward propagations that we try to calculate the loss. And then once we have the loss, we do the backward propagations that we calculate the gradients. And based on the gradient descent, we take a derivative of the gradients. With the gradient descent, we can update the parameters. And by updating the parameters, we can try to reduce the losses. So let's see how we can do it. Previously, remember this loop. This loop corresponds to two steps of calculations. And the first step is that we compute the weighted sum. We take the inputs and compute the weighted sum. And then in the second step, we compute we pass this weighted sum through a sigmoid functions. And here, the weighted sum, we call it Z. That is we compute the Z value. And then the second step, we use another notation that is an A. That is the values after the activations functions. Here we assume the activation function is a sigmoid. That means that means we take we apply a sigmoid functions to the weighted sum. That is a Z, and then we get out the value. That is the probability. That is an A. In this example, we assume there are three values. That is x1, x2, and x3. And in that case, you can see that there are three weight parameter. That is W1, x1, W1, x2, and W1, x3. Very quick remark on that, on the notations. Here, Z11, where the bracket with the 1 is the corresponding layer. And then the 1 without the bracket represent the corresponding node. So that means these Z11, the first one, that is the first layer. Here is the first layer. And then the second one, that means this is the first node. We just calculate the outputs from the hidden layer node 1. Now we can also perform similar calculations for the hidden layers for the node 2. That is to take the inputs and calculate the weighted sum, and then pass this weighted sum through the sigmoid functions to calculate the output from this hidden layer 1, node 2. Just a point to note, Z, W, and B, A are all vectors, and sigmoid activation functions can also be applied element-wise to Z. Therefore, vectorizations can be applied throughout this whole process to avoid any for loops that could improve the overall efficiency. I will not go through the details of these vectorizations, how these perform, but just a very quick information for that is that it's just like stack the nodes for each of the hidden layer. Say for example, in the first hidden layer, we have 2 nodes. So we stack them together. So you can see that the overall affidavits can be included or can be incorporated within the matrix. That means vectorizations can be performed. For the notation part, because all the vectors and matrix are combined, and so we try to remove the subscripts to represent them as their corresponding vectors and also the matrix. And here you can see that the final form is quite simple. Just W1, that is the first layer, times the input, and then plus the bias, and then we got the Z1 from this first layer. And then based on the activation functions of the C1, we got the A1s, that is the probability that we get from this first layer. And we have one more layers in this neural network. So another node in the second layers will corresponding to another Z value. Similarly, we can take the input from the previous layer and then calculate the weighted sum. This is the input, and then this is the weighted sum. And we will pass this weighted sum through another sigmoid activation function. And then the output will return a value between 0 and 1. That is an output of probability between 0 and 1. And of course, we can then calculate the loss and also calculate the cost. Just like what I mentioned before, loss is just one sample because we have so many, we have at least more than one sample in all the cases. We need to calculate the cost. That means we take a summations and then we take the average. Once we have these cost functions, we are ready to perform the backward propagations. And in that case, we can calculate the gradient with respect to the weight and also the bias. That means we are going to take the derivative from these cost functions, just like what we've done in the logistic regressions. And of course, we can set the learning rates and for training up the neural network. And then we can update the parameters W and B. A very quick recap in neural network, the full training algorithms. The training process involves 3 key steps that includes a forward propagations to calculate the loss. And then once we calculate the loss, we perform the backward propagations, and then we can calculate the gradients. And using gradient descent, we can update the parameters. Now we put everything inside a loop, and we determine how many we can use the epoch to determine how many iterations that we would like to have in order for us to continue to improve the parameters weight and also bias. And that's it. And I hope now you have a better ideas about the full training algorithms of neural network. If you want to know more about the vectorizations, please feel free to check out my neural network full course in another videos. I have a detailed explanations in that video. It's time to build your first neural network, and we will do it together in the next video. See you in a bit. Bye-bye.